The last aspect of electron displacement method that I would like to treat now is hyperconjugation system. Yeah, sorry, it's not the last aspect. I would like to add what we call steric effect. Steric what? Effect. We deal with what the bulkiness of alkyl group to the central reaction central carbon atom. I would like to explain it. So the next one that I would like to explain now is hyperconjugation effect. Hyper what? Conjugation effect. See, what is hyperconjugation effect? Before I will explain hyperconjugation effect, please permit me to explain the alpha carbon atom and alpha hydrogen atom. Please, what is alpha carbon atom and alpha hydrogen what atom? Let me explain them first. Alpha carbon atom. Alpha carbon what atom and alpha hydrogen and what? An alpha hydrogen atom. Let us explain these two first. What is alpha hydrogen atom? Alpha carbon atom. Alpha carbon atom is what? Alpha carbon this symbol alpha what? Carbon atom is the first carbon atom attached to a functional group. Is a what? A carbon atom that attached to a functional group. We call it what? Alpha carbon what? Atom. Take for instance here. Take for instance, if I have CH3, sorry, CH2 double bond, CH2 bond with CH3. Good. Please, what is the functional group of the structure? We hope that what the functional group is what is in. So this is the what? Functional what? Functional group of this structure. But what carbon attached to the functional group? This is the carbon that attached to what? To functional group. So any carbon that attached to the what? To the functional group directly are called alpha carbon. So this carbon, call it what? Alpha what? Carbon. So if alpha carbon is this, what is alpha hydrogen? Any hydrogen atom that's attached to the alpha carbon are called alpha hydrogen. How many hydrogen attached to this alpha carbon? 3. So the 3 hydrogen we have there are called what? Alpha hydrogen. Hello? Once again, any carbon atom that attached directly to functional group are called what? Alpha carbon. The hydrogen that attached to that alpha carbon are called alpha hydrogen. Let me add another more example. If you have a compound like this, see this one, CH2, good. And now say what we have, let me put it here. Let me cancel this first, please. CH2 I will have CH, this double bond here. And now put another what? CH2 here, another CH2, another CH2. Now what? C what? CH3. No? Excuse me. I'm not satisfied with the example. Let me say we have CH3, CH2, 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 bond with H, double bond, and we have H2. Look at this structure. What is the functional group here? The functional group here is this. Two what? Two in. These two in are the functional group. This is the functional what? Functional group. Good. So the first carbon attached to the functional group is what? Is this. So this is what? Alpha what? Alpha carbon. Here, this is what we call what? Alpha what? I call it alpha what? Alpha carbon. The carbon that is attached to what? To functional group is alpha carbon. But the second carbon that attached to what? Functional group, that one will be what? Beta carbon. The third carbon attached to functional group are called what? Gamma carbon. The fourth one are called delta carbon. If you are not asked now, how many alpha hydrogen do we have in this compound? We have two. How many beta hydrogen? We have two. How many gamma hydrogen? We have two. How many delta hydrogen? We have what? Three. So what we need here is what? Is alpha carbon. We are not concerned about beta and gamma and others. Carbon that's attached, the firstly attached to the functional group is called alpha carbon. So how many hydrogen are attached to it? Two. These two alpha what? Hydrogen. Let me add more example. Okay, in the case of we have what? C now. Okay, we have CH3, C double bond, no, CH3, H, CH, CH3 double bond. Here we have double bond there, good. Look at this compound. The first thing we need to locate is what? This is our what? Our functional group. Don't forget. This is a functional group. Abi, this is the what? The functional group. The F group is this. How many carbon attached directly to functional group? This one attached directly to functional group. This also alpha carbon. But it's also what? Alpha carbon. So in this structure now, we have what? We have two alpha carbon. Abi, the first one here, the second one here. How many alpha hydrogen we have here? Three. We have three. Add it together, six. And we have what? Six alpha I what? Hydrogen. Are we? Can I put one example of alpha carbon and alpha hydrogen? Okay. If this one is six altogether, yes. Let me ask you this question. Take this cyclo, I give you this structure, and I put what? Plus ion here. This plus ion we have here, this serve as what? As functional group. You are now asked how many alpha carbon we have there and alpha hydrogen. To solve this question, it's very easy. Do you agree that this compound can also be in this form? CH2. CH2, 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 CH, bond, 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 good. We have what? Plus here. This is the same. Are we? So if we agree that what? This positive charge we have on top here is the functional what? Group. This is what? Functional what? Functional group. And I said carbon atom that attached to the functional group is called alpha carbon. So here now, we have this is the what? Carbon here. We have carbon here. This is it. So this carbon we have here is alpha carbon. And what we have here is alpha carbon. So automatically in this structure, we have two alpha what? Carbon. So how many hydrogen attached to the alpha carbon here? Two. Here we got two. Then we have what? Four alpha hydrogen. Abi? Let me add more example in the compound of CH3, good, CH2 plus. In this compound, how many alpha carbon and how many alpha hydrogen? This carbon ion here is the functional what? Group, Abi? So the carbon that attached to it is alpha carbon. Here we have one alpha carbon and we have how many hydrogen? Three alpha hydrogen. Let me add the last example of alpha. In case of we have what? Ethene. No, butene. Mm-hmm. Mm-hmm. Uh-huh. Let me add this one too. Good. Let me add what? Hydrogen here. Look at this compound. How many alpha hydrogen we have here and how many alpha carbon? See, this is the functional group. These two. This is the what? Functional what? Functional group. This one is alpha carbon, alpha carbon, alpha carbon. Carbon atom that attached to the functional group. So here we have what? Three alpha what? Carbon, three here, hydrogen. So we have how many hydrogen? How many alpha hydrogen? 3 plus 3, 6, 9. We have 9 alpha hydrogen. See, good. We can identify the alpha carbon and alpha hydrogen now. We are now good to move to the hyperconjugation effect. But the hyperconjugation effect is deal with what? Is the shifting of sigma bond electron in alpha is the shifting of what? Of sigma bond electron of alpha hydrogen in alpha what? Carbon. So if you don't understand the concept of alpha carbon and alpha hydrogen, you won't be able to what? To understand the conjugation effect in a what? In a compound. Yes. So what is hyperconjugation effect? So the hyperconjugation effect, I can say, is the shifting of sigma bond electron of alpha hydrogen. Is the shifting of sigma bond electron of alpha hydrogen to a vacant orbitals. Shifting of alpha sigma bond electron to a vacant orbital in order to increase the stability. So the major function of this hyperconjugation is what? It majorly explains the stability of compound. 1. Let us, the definition, let me define it. Hyperconjugation effect. Hyperconjugation effect. Hyperconjugation is the shifting, is the shifting of sigma bonds electron of, don't forget alpha what? Hydrogen to vacant p orbital. The vacant b what? Orbital. To increase. To what? Increase what? Stability. The main purpose or function of hyperconjugation is to increase the stability and shorten the what? The length. That is what hyperconjugation. Take, for example, now, thank God I've explained the alpha hydrogen for you, Abi. And yeah, take this compound. If you have a compound like this, carbon with hydrogen, 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 bond with another carbon with this. Note that this carbon here will have positive charge here. This is a what? A functional group. And this carbon, you see what? Is a vacant p orbital. So in this structure, the carbon that's attached to these ions is what? This is our alpha what? Carbon. Abi? So, and how many alpha hydrogen do we have here? We have 3. Good. So the conjugation effect, I said, is the shifting of sigma bond electron. Sigma bond electron means a single bond of alpha hydrogen to the vacant p orbital. That is, here, this orbital we have here is vacant. The orbital we have here is what? Is vacant. So that's why you put a plus here. Because of 2 electrons. So this alpha hydrogen, we have how many alpha hydrogen here? 3. Since we have 3 alpha hydrogen here, this compound can undergo 3 conjugate effects. 3 what? Because the number of alpha hydrogen present in the compound is equal to the number of what? Of the conjugate effect we have or resonance structure we have for the atom. And increase the number of what? As the number of alpha hydrogen is increases, the stability of that compound is increases. Let's check now. If this is alpha hydrogen, still the sigma bond will now shift towards to this side. Good. It shifts to that side. When it shifts to that side, sorry, don't let me use that side. Let me use the carbon. Sorry. It shifts to what? To the empty what? The empty carbon. It shifts where? To this empty what? Empty carbon. When shift to this empty carbon, we are going to have what? Look at it. We are going to have a reversible reaction of this kind. And the structure formed here is carbon, hydrogen, hydrogen. This hydrogen remain here. Note that the bond that linked the hydrogen to carbon, it has already what? Transferred to this side. Good. You now have single bond. You have the single bond here, carbon, the hydrogen here, the hydrogen here. Do you realize that what? This electron has moved to this side, Abi? So here now, you will now have this orbital we have here, and the orbital we have here. Good. Note that this pi have come here, and this hydrogen now become asterisk. The hydrogen will be here without bond. So therefore, this hyperconjugation effect, we can call it what? No bond resonance. Because there's no bond between this hydrogen and what? And carbon. And the bond that is come to this side, the bond is with those, this is this here. Are we? And again, do you know that if that's for this what? For this first alpha hydrogen, Abi, but assume that this one remain here, and this alpha hydrogen here is the one that transfer its sigma bond electron to this side. If this one is what that is what transfer its sigma bond electron to this side, what happen here? We are going to have a reversible reaction like this, and we have the hydrogen here. We have carbon with hydrogen, carbon with hydrogen. We have carbon, hydrogen. We have hydrogen. We have what? Hydrogen. So this side we have what? This is it here. Good. Abi? You can ask it as what? Is this one that denotes the sigma bond? Abi? This is sigma bond. So between this hydrogen and carbon, there is no bond here. So this one we also have what? Plus. Or asterisk. If this that denotes what? Is sigma bond to what? To the MTP orbital here. Is what this is what we have. And then we have what? The bond what? Here. Abi now? So if the third hydrogen donates its own what? Orbital. Assume is this what? This third hydrogen that donates is what? Its own what? Orbital to this side. What will happen? We have what? This one we attach to carbon. This one we also attach to carbon. This one we also serve as empty. We add with this. We have the H here. So this is the one we called what? This one the without what? Without bond. And here we have this. Here we have empty p orbital. Then the bond here we have what on top here. We can now say that is what? For this ethyl carbonium ion, this structure we call it what? The name of this structure is what? It's ethyl carbonium ion. So the ethyl carbonium ion, it has what? How many resonance structure? It's 3. This is the first one. This is the second one. This is the third one. Depend on what? On the alpha hydrogen that donate is what? Is sigma bond electron. So this is what? The resonance structure of ethyl what? Carbonium what? Carbonium ion. And again, the resonance structure, hello, from this expression now, we can observe or deduct from this expression, we can deduct that is what? The resonance structure and the hyperconjugation what? The hyperconjugation effect. We can also call it what? Yes, let me write it here. We can also call it hyperconjugation effect. We can also call it what? One, also known as what? No bond resonance. It is also known as no bond resonance. Why? Because there is no bond. There is no what? no bond. Because there is what? There is no bond between this carbon and this hydrogen. What? No bond resonance. Number two, we can also call it what? Sigma pi resonance. You can also call it what? It can also call what? Sigma pi reso. It is a hypothetical what? Process. It's not occur in a real life. Yes, this hyperconjugation, it can occur in three places. The hyperconjugation can occur in how many places? Three. Or, let me write it down. The hyperconjugation can take place in three places. The hyperconjugation can take place uh, in three what? Places or three compound. And the compound, I call it curve. What do I call it? Curve. The hyperconjugation can always occur in three kind of compound. And the compound, I call it what? Curve. These four C stand for the what? Carbonium ion. Example carbonium ion is what it is. Any organic compound that contain carbon plus ion are called carbonium ion. This hyperconjugation can also take place in what? In alkene. What do I call it? Alkene. A double bond functional group. The last one, hyperconjugation, take place in free radicals. So let me explain the three scenario of hyperconjugation. It's very easy. Number one, the first one, hyperconjugation in what? Let me write hyperconjugation. Let's start with CAF. Abi? CAF is what? Carbonium ion. Abi? Let me say what? Hyperconjugation in carbonium ion. We can also call it what? Carbon cation. What is a carbon positive what? Charge. Let us look at what? This thing in it. Let me assume that I'm having a carbon compound with hydrogen, alkene group. This thing may be anything. That's why I use what? Alkene group. Bond with CH, double bond CH2. Good. Like this. Please, in this structure, what is alpha carbon? This is the functional group, double bond. No, 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 no. I'm looking for the example of carbon cation. Carbon what? Cation. Let me put what? Not carbon. Let me put C, yes, and H2 plus here. Good. Because of the presence of plus here, this compound is called carbonium ion. So this is the functional group. As you all know, this will be the what? Alpha carbon. And if this is alpha carbon, how many hydrogen attached to alpha carbon? One. So we have one alpha what? Hydrogen. Since we have one alpha hydrogen, how many hyperconjugation effect structure does this compound we have? Is one. Because we have one hydrogen here. Look at this one. That is have what? 3 alpha hydrogen. It has what? 3 resonance structure. Hope you are getting it now. So let's do this one now. So what happened? This alpha hydrogen with shift is sigma bond electron to where? To this empty what? P orbital. If it shifts it to what? To empty P orbital, we are going to have, it is a reversible what? Reaction. So here I'm going to have what? A key group with carbon, we have empty hydrogen, we have what? This C, this one is what? Is there already. So when this is what is moved to this side, it will become CH2. Good. And at this side now, what are we going to have here? We have the no bond hydrogen. So there is what? The carbonium, we have amine structure 1. So the hyperconjugation takes place in carbonium ion. This is a good example of it. The next one is what? The hyperconjugation CAF A. It takes place in what? In alkene. The next one is CAF A is what? In hyperconjugation in alkene. This A stands for what? Alkene. So the hyperconjugation takes place in what? In alkene. And the common example for alkene is, let me use this compound. We have R with carbon, and we have hydrogen with alkyl group. Yes. Let me put what? CH here and double bond A2 here. Good. This is alkene. That's what? Here we have double bond. Alkene. Here we have what? Plus CAF in. So here we have reversible what? Reaction. And the last aspect, it will be what? When this so when this what? Sigma bond of hydrogen shifts to this side, like this. When it shifts to that, this pi bond will come to this side. As a result of that, we are going to have what? RCr, we have H, here we have double bond H, we have C, A2 minus. So because this bond come to this side, here we have minus, this come to this side is positive, then here we have what? Our empty hydrogen bond. This is what? The illustration of hyperconjugation in what? In alkene. And this example is illustration of hyperconjugation in what? In carbonium ion. So the last one, CAF, free radical. A hyperconjugation in free what? Free radical. It's like I've explained free radical. They are atom or group of atoms that have a low pair of electron, and they are neutral. They are electrically neutral of an atom that have low pair of electron, and they are highly reactive. Free radical. So they will always use what? Dot. If I have a dot, means a radical. If I write what? P dot, simply means what? P radical. If I write what? CH3 dot, simply means what? CH methyl radical. So we use dot to denote what? Radical. And they are the product of homolytic fission. So let's check this free radical. So in this free radical now, we can have what? A compound like this RCr, and we have what? H here, bond with CH2. Yes, and we have what? A radical what? Radical here. Can you see it? Instead of apple plus, we have dot. This dot means what? That what? Radical. And it's also happened here too. We have this reversible reaction. So when this man is what? Shift a lone pair of electron here, one electron transfer from this side. This dot represents one electron too. This also releases what? Is one electron. Now I've told you before that is what? The full arrowhead is what? Is so one electron move from here, the one we have also move to this side. As a result of that, we are going to have what? R, CR, we have double bond, we have CH2. So that's what we have here. And don't forget, our this H is still remain here, which is what the no bond what is. So if you have to give me a question in the exam, which of the following does not undergo hyperconjugation effect? Check it. If the compound is contained positive carbon ion, is what? Carbonium ion, it will undergo. If it is what? It has double bond, it will undergo. If you have dot radical, it will undergo. These are the three common examples of what? Hyperconjugation. The last aspect of hyperconjugation for today is application of hyperconjugation. It has just two functions. The first one is what? Is reduce, let me say, it results to the shortening of the what? Of the bond. Look at this side. Look at this bond. I said it results to the what? Shortening of the bond. If this is a single bond here, Abi, assume if the distance here between this bond, between these two bonds, assume I'm using assumption though. If the distance between this bond is what is 0.1, 0.5. So when this is come to this side now, you see what is this double bond, Abi? The distance we want to reduce to what is 0.1. So the first application of hyperconjugation is what? It's resulting to the shortening of the bond. If you remember, bond length. So this is what? sp3 hybridization. One is what? sp2 hybridization. Abi, as the S character increases, sp2, sp2 hybridization and sp2 hybridization, sp3 hybridization. Abi. So for the sp2 hybridization, they have what? Long bond length. So, but don't let's reduce when the what? The hybridization is what? sp2. The one we have in sp3, ordinary sp, is shorter than what? Than this. As the bond increases, the bond length is what? Reduces. So that is what? The first application. Now, what are the application of, let me write it up, application of, application of, let me rub everything. But before I rub it, I want to use this to explain the first one. Is result to the shortening of what? Of bond. In a single bond here, this compound, we have 0.5. When it's moved to this, it becomes double bond. What happens? The bond will be what? It reduces. The same thing happen here. If the bond here is what? Is the bond length is 0.5. What do we have here? Double bond. Shortening of the what? Of the bond. That's the first application. Let me rub the board and explain the two. The second application, what? This hyperconjugation has two functions. The first one is shortening of the what? Of the bond. Number two is explain the stability of three compound. One, stability of what? Of carbonium ion. Stability of what? Of free radical. Stability of what? Of carbonium ion. Stability of what? Of alkene. And stability of what? Of free radicals. So that's it. And let me explain the stability, what we call it today.